week 11, 12 revision session.
Ma'am, what about week 10?
Okay, we will conduct one more session if possible.
Okay.
Hello everyone. Today we are going to have revision session for week 11 and week 12. The topic is hypothesis testing. So, yeah, what do you know about this test? Anyone can explain, can brief why we need this hypothesis testing and all? So, see, from the starting of the course, we learned what are the random variable, how the distribution works, and what are the CDF, PDF, this kind of things we have learned, right? Then samples, we learned about the samples, some central limit theorems, and all this stuff. All these things were used to work on when some data is given to us, and we were finding like what distribution, which distribution the data is following. And that kind of study was known as descriptive studies or descriptive statistics, because we have some data and we used to find what is the distribution followed by this data, or for particular some variable what the distribution, for example, in a class, if there are some 1000 students, then if we are measuring the height, then what the distribution it is following, or if we are calculating the marks of students scored in particular exam, then we will find what the distribution, the marks obtained by student is following, and all this stuff. So we had data, and we were finding what is the mean, median, and all this stuff from the data itself. Now the question will be, if uh, if data is given to you, some particular, some about, let's say, there is some village, and in that village uh, there are, let's say, some 3000 peoples are there, and you are predicting what will be the average height there. Then what will you use there? If 3000 peoples are there, you will just measure the height and take the mean, right? But if it is about a large population where it is not feasible to calculate everyone's height, and we are being asked to what will be the height of the next person or next generation, what will be the average height for the next generation. In that case, we will what we will do, in that case we'll collect samples, some random samples means what which what will be our samples. Anyone can answer that. If the question is, uh, we have been asked, for example, in any country, uh, you have we have to measure what will be the average height of uh, the people, the what we say, children whose age is below 5 years. What will be the average height of that children after some 20 years? Okay, are you getting my question? There is some population in a country, let's say, and we are seeking for the average height of the children after some 25 years. Okay, so what we will do, we will collect the samples, the random samples. That means they are nothing but the human being, right? So there is certain limitation for height as a human being. So yeah, infer from small data. So as we say that we have to take some random sample, we will measure their height, have some average, and then we will also measure what are the variance and whatever required things are there, and based on that we will predict or infer the average height of the after some 25 years of the children's. Okay, so the question is, what will be your sample in that case? So obviously you are measuring the height of human beings, so you have to collect the height from some peoples who are at this position. When you are measuring stuffs, their age must be above some 25 to 30 range people, right? And you will average it, and based on that you will predict the height of the required what we say targeted audience. Okay, so this kind of stuff, inference, this kind of things we called as inferential statistics, where we have the data of samples. Okay, we have data for sample. Sampling data is available to us. Sometimes in that sampling data also, we sometimes the mean is unknown. Maximum of the times actually mean will be unknown to us, and we will be testing for the mean of the population by using the data of sample. Okay, and sometimes the variance will be known, and in many of the cases the variance will be unknown. Okay, or unknown. This kind of scenarios will happen, but always we have some data, and on based on this given data we will predict about uh, the things which is unknown to us. This is the aim for hypothesis testing. Now how it works, that is the question. Is it clear, like what are we going to do using hypothesis testing?
Yes, ma'am.
And okay, fine. So generally, if we are checking any fact, or if we are searching for anything, then obviously from this sample we have some idea or some hint is given to us. Let's say, for example, we have a scenario. In that case, it is given that, for example, in India, in particular any city, they predict in this summer there will be a highest temperature of 40 degrees Celsius. Okay, the average temperature they are talking about in the, let's say, the average in May to June. Okay, and they are averaging the temperature of all the 60 days from May 1st to June 30th. Okay, and they says the average is 40 degree. Now uh, the some people says that no, the average will not be 40 degrees Celsius. It might be greater than, or someone will say no, this year there is sometimes rain is there, and temperature they are feeling that no, it's low only. So they will say the average temperature will not be 40 degrees centigrade. Then the question is how we will predict whether the claim by, let's say, given by some team which says that the average temperature in the summer for a particular city in May to June will be 40 degrees centigrade. So how to check that whether it's correct or not? How will you do that? What will be your sample in that case? And how will we predict or get to know that whether it's going to be like that or not? So for that, there are several tests are there which will help us. Okay. So any idea how to proceed with this kind of problem? So yeah, anyone?
Ma'am, can you repeat the question?
Okay, the question is there is some prediction about the mean for this time period, May to June 24, that the average mean of the average temperature in this year, in from May to June in particular city will be 40 degrees centigrade. So how to check whether it will be a 40 degree or less than 40 or greater than 40? So let me just continue it. So for this kind of problem, what we will do, we will collect the sample. What our sample will be? That will be the data of the average temperature of the month May and June, May to June of previous years, right? We'll collect that and we will have the average, like what the average is generally in this months will be like that. Okay. So let's say our mm, so now hypothesis tests work like that. We have a problem. Now we will create two hypotheses. One is called null hypothesis, denoted by H naught. We are saying that, which says that what is the fact there. So we are claiming the team is claiming that the average temperature will be 40 degrees centigrade. So our null hypothesis is, let's say, 40 degree centigrade. Okay. And some other team is rejecting it. No, the temperature will be, let's say, less than 40 degree. Okay. So that is called as alternative hypothesis, which will be always opposite to the null hypothesis. Okay. Alternative hypothesis, which says that so it is generally denoted by HA, or some will denote it by H1. Okay. Alternative says that no, mean will be let's say less than 40 degree. Okay. Average mean will be 40 degrees centigrade. And we'll assume that these random variables are normally distributed and they have some mean also. Let's say these xi's, that is the temperature measured, are IID samples and they are normally distributed with some mean, and let's say variance as 4 square. Fine. Or in short, I want to say that this is a case for the known variance. Okay. So this is the thing. This is the setup. Now the hypothesis test works with this two, and the next step is define what is your test statistics. So in this case, we are testing for mean, right? Yeah. So what will be our test statistics in this condition when we are going to check about the average temperature?
Total mean?
Yeah, it will be a mean, but of what?
Sample mean.
Sample mean, right? So our T is nothing but X bar, sample mean, and we are testing it against, let's say, reject our null when, yeah, what will you decide for this T? When will you reject null hypothesis? So obviously, the alternative is about is saying that the temperature is going to be less than 40 degrees centigrade. So what will you decide for your test? When will you reject H naught?
When mu is less than 40 degrees Celsius.
T is less than
T is less
C.
than.
Not exactly 40 degree. We will just have some scope for it. So that's why we say it as a C. Okay. As whenever whenever we define a test, we do not stick on a particular equality sign. Why it is so? Because we need always a region, not a point. Okay. So generally there are large samples, so distribution will be kind of normal because the samples are following normal distributions. Okay, and this will be your sample means. Fine, and this is your population mean somewhere here. And if you say you will reject H naught when T is taking any particular value C instead of T less than C. That means what are you saying? Let's say this is some value C, okay? So whenever we say that instead of T less than C, if we say T is equal to C, at that time reject H naught. That means whenever your sample mean will attain this value, you will reject your null hypothesis and say that okay, alternative is true, null is false. So what is your rejection criteria in this particular setup? Whenever the sample will attain this point only, at that point only you are going to reject, otherwise you will going to accept your null, right? But why we select that reject H naught when T is less than C? Because if, as I said, T is less than C, so I am moving my C from here to, let's say, here only. Some C is there. Whenever your null hypothesis will lie on this region, we will reject null hypothesis. So, in this case, when we were taking C1 here, in that case, there was only one point where the null hypothesis was wrong. Otherwise, always we are going to accept the null, right? Are you getting my point? Why we do not take this T is equal to C1?
Yes, ma'am.
Okay, so that's why we. So in this case, we are getting only a 1 point for rejecting null hypothesis. So that's why will not work with that, because that will not be that much suitable, as this is there are uncountable combinations of random samples. So there is very, very, very less chance that our sample mean will be exactly equal to our rejecting point, that is T is equal to C1. So that's why we will take this, and that will be a unfair test, right? So we will have this region whenever this sample mean will fall into this region, we will reject our null hypothesis and accept our alternative hypothesis. So now the question, yeah.
In this case, we are assuming null to be 40 degrees.
Yes,
which
null
is
to be,
very
yes.
Which is very rare.
Why?
Because there is only 1 point and sample mean may not be exactly 40.
Mean will not be exactly 40. Okay. Like I am not getting it. This is average temperature of 2 months.
Yes, and we are assuming null as exact 40 degrees.
With
And,
variance 4 square.
Yes, ma'am.
With variance 4 square means what?
Plus minus 2 degrees.
Yeah.
And
Okay.
And alternate we are assuming is less than. Why can't we assume more than 40 degrees?
This one?
Yes, ma'am.
Okay. This is just a I said no. This is just a hypothesis. That's how I constructed the question.
Okay.
If we construct the question like that, okay, instead of
for same question, can it be alternate more than 40 degrees?
Yes. Or you can have this kind of information also. Let's say the team 1, okay, let's say research team 1 is saying that the average temperature this year in the month May to June will be greater or equal to 40. That is also fine. You can have this kind of situation also. Okay.
So, ma'am, Answer will not vary on this, on our hypothesis, what we are thinking, because taking it less than 40 degrees also correct, and taking alternate more than 40 is also correct.
No. Answer will affect definitely. It, in statistics, everything depends on the context of the question. So I don't think so.
Okay, but
Whether
it will be,
Yeah.
this idea we can get from the context of the question. Right?
yeah, that is from the context of the question only. I don't think so. Like I think uh, you may have missed some part when I was describing the question. So let's have this kind of stuff. Let's say the team one is saying that the average temperature is going to be uh, greater or equal to 40 degrees centigrade in this 2024 year. Okay, June 2024. Fine. And then some team two will come and they are going to say, they are saying that no, your prediction, your claim is not correct. They think the average mean average temperature in this time period will be less than 40 degree, right? So to check whether the team one is correct or team two is correct, for that we are going to have this kind of setup. Okay, or even though there are not team one and team two, only you have to check whether the team one who have given to you that average temperature this year will be more than 40 degrees centigrade. You have to check that whether it's true or not. For that you will create your alternative. See, what do you mean by hypothesis? That is some sentence that is not verified or like that, right? That is not complete truth, or there is no proof for that sentence, right? So if someone is giving one hypothesis and we have to check whether that statement is, whether that sentence is correct or not, we will generate an alternative hypothesis which will be always against that statement one, and we will check for that. Okay. So we say that, okay, we will reject the null hypothesis when it was less than some point C. So now how to proceed with that? So there is one, for every test in mathematics, there are some metrics that will help us to uh, check whether the particular thing is going to be in favor of the null hypothesis or alternative hypothesis. One of the thing is significance level. So significance level is a, let's say it's denoted by alpha. This is a number, or it will give you the accuracy of your test being like test result will being correct or incorrect will be generally we take it as 0.05. So this is kind of your error margins, that whenever you are going to have correction for your test up to 95%, then we will use our significance level at 0.05% or 5%. That means 5% margin is there that our test may or may not work properly, but we have confidence for 95% confidence interval that test is going to perform well. So now what is significance level? Its easiest criteria to measure is nothing but the probability of type 1 error. So do anyone remember what type 1 error was?
Yes, ma'am. Reject H naught when H naught is true.
Yes, ma'am.
Right? Probability of rejecting H naught when it was true. So in this particular case, what will our test will be like that? So probability of rejecting H naught, that means the T, the sample mean, will be less than C, given that H naught is true. That means mean is greater or equal to 40, right? So we know that this T, that means sample mean, will be following what distribution? Mean will be mu, and xi will be, sorry, sigma square will be 4 square by n, right? So I will convert it into a normal form, that is t subtracted from the required mean, because we are saying that mean is true, right? H naught is true. So what will be nu naught here? N.
Sigma by root n.
Yeah. So what will you take in the at the place of nu naught? That is the question. 40, right?
40.
Okay. So just put all these values there, and yeah, from this information, what are you getting there? Square root n. Yeah. From this information, how will you solve the question? So if t is following some distribution and we are normalizing it, this particular random variable is going to follow normal distribution with mean 0 and variance 1. So once you know that this particular random variable is going to follow a z distribution,
We'll take z.
then yeah,
Probability of
so
z less than c minus 40 upon sigma upon root n.
sigma square root n. Okay, fine. Then if your
One.
z is following
Yes,
z
ma'am.
is normal distributed, so this is nothing but CDF, right?
fz of c minus 40 upon sigma upon root
Fz of c minus 40 upon sigma square root n, and we know that we are calculating at a significance level of 0.05 using inverse of this all this
inverse.
stuff. We will get to know some value of c. Let's say some value of c will be obtained to us, let's say some 41, or let's say 41 only. Okay, let's say we got by solving this stuff, we got the value of c as 41.98, let's say. Okay, in that case, now what will you do? You got the
We
value
will
of c as
reject
41.98. So they said whenever the t is less than c, you are going to reject the null hypothesis, and c came out to be 41. Or let's say instead of 41, just take it as, okay, fine, 41 is also 41. Okay, now you measured the temperature, and that came out to be 39. Now what will you do? Your t is less
we
than
will reject
c, right? Yeah, will reject the,
reject.
okay. So just to avoid confusion, I am just making it 39. Okay. Again, what will you do? Again, our t is less than c. That implies reject null, right?
Yes, ma'am.
Fine. Okay. So in this way, this things works like that, or it may possible that at a value, for example, we calculated at a significance level of 0.05, instead of this 39, if there was 41, and you got your temperature as equal to 40, still you will reject your null based on the taste. Okay, so this taste is known as Z test. Okay, this was the Z test. Now there will be another scenario where some xi's, x1, x2, xn will be a random
Z test
variable.
is same as that we have been doing
Yeah,
before.
what?
Z test is same as that we have done before.
Yes, this is Z test. What
Yes,
we
ma'am.
did is known as Z test. Why it is Z test? Because this normal distribution 0, 1, also known as Z distribution. Okay. So let's say xi's are some IID normal random variables where it has some mean and variance, but variance is unknown to us. and there is some claim for the mean that that mean is equal to some value. Let's say let's take any value, let's say 15. Some context is there, and we are going to check about, or instead of 15, let's take it as mu naught, so that it will be a generalized. So XIs are IID normal samples having someone is claiming that the average mean will be mu naught and sigma, like your variance is unknown to us, then check whether this claim is correct or not. So what will be your procedure? We will perform the same procedure. If claim is like that, we will we will create or assume our null hypothesis, which says that mean is equal to mu naught, and there will be a alternative hypothesis which says that it is not equal to mu naught. Okay, depending on the context, we will decide whether it's greater, less, or equal kind of thing. Okay, so instead, okay, fine. So in the last question we took it less, so just take mu is greater than, some point. Okay, depending on the context, this sign will be decided by us. Okay, this will not be given directly. Sometimes they may give you directly that this is your null and this is your alternative hypothesis, but we have to decide based on the question. Okay, so null hypothesis, alternative is both are created. Then what next? What will be your test statistics? So given this information, can you just tell me what will be your test statistics?
Less than C.
Less than C will work there.
Yes.
No, ma'am, greater than C.
Greater than C.
Greater than C.
Yeah, greater than C. Why it is so? Reject null whenever T is greater than C. T is greater than C. If you take T less than C, then indirectly you are favoring this null hypothesis. So whenever you create a test, be careful that your null hypothesis and alternative both should be totally independent. There should be no intersection between them. If we say that C, if the value C, that is known as critical value, if critical value, if you say the critical value is less than some P is less than some C, and here we have assumed our alternative to be greater than mu naught, so that cannot work together. So that's why we have to take like that. Okay, can you just tell me which kind of test it is? Like someone in the last session, they were saying one-sided, two-sided test, left-sided, right-sided. Which kind of test it is?
Right-tailed test.
A right-tailed test. Okay. So generally, to clarify with that, we just have this normal distribution. And we are saying that our rejection area is whenever the T is greater than C. So let's say somewhere C it is there, and yeah. So it is a right tail test. Okay. So this is our acceptance region. And another one is rejection region. Okay. So how do you calculate value of T? We said that if T is greater than C, then how to calculate the value of T? Now, using this information, you have all this stuff, and now the question mark is how to calculate T.
T is something, na?
Yes, T is something. What that something is? I'm asking
X
that.
bar mean.
Yes, it is sample mean.
Sample mean.
Okay. For this particular scenario, After this question, I will take another scenario. In that case, the value of t should be changed. The sample mean will not work there. Okay, can anyone give me the reason why we take t as a sample mean?
Because we have to find the average.
We have to find, or what? We are finding here something?
Not
Ma'am,
finding,
because
but
test,
average.
ma'am,
Mu
test
is
statistics is a
unknown.
function of samples.
Okay. Can you please answer one by one?
We have chosen t is equal to x bar because test statistics is a function of samples.
Okay. But what if you take the t as sample variance? That is also a function of sample variance only.
Because mu is a consideration. So we are taking sample.
Sorry, your voice is not clear.
I'm saying because mu is in consideration, so we are taking sample mean.
Yes, exactly. We are testing against the mean of the particular thing, right? That's why our test statistics should be this one, mean on sample mean. Just a minute. We have to infer about the population mean, right? From this information, we will see the framing of the question, how beautiful it is. There are n random samples whose distribution is known to us, and the question is being asked about the whole population. Based on some finite number of samples, you are going to infer about the large population, right? So you have, from the given samples, you have only one thing. You can calculate the sample mean, which will be calculated from your n random samples, right? And based on that, after applying some testing, hypothesis testing on it, you will predict whether your population mean is going to be equal to nu naught, or will it be greater than that nu naught. Okay, so that's why these are the this is the concept that you will use many times when you will work in the real life problems. Okay, so as we are going to predict about the population mean, the only way that we can predict the population mean, we have at this situation in hand our sample mean. So the sample mean will be our test statistics, and if the sample mean will be greater than some value c, which is known as critical value, if the sample mean is going to be greater than that c, then we will say that the average mean of the population will not be nu naught, it will be definitely greater than nu naught. Okay, that is what the language we use when we have this kind of hypothesis. Okay, so again, let's say we are checking the test statistic at a significance level of 0.01. So this is actually more accurate thing when we take significance level 0.01, because if you convert it into a percentage, then your confidence interval is 99% level. That means you are 99% confident about your answer. Okay, so significance level 0.01. So how to calculate for that? So alpha, that means significance level, is nothing but the probability of rejecting null when it was correct. H naught is true. So what does it mean by H naught is true in this particular case? And what is rejecting H naught? Rejecting H naught is nothing but
T greater than C.
C. Given that, what is H naught is true?
Mu is equal to mu naught.
Mu is equal to nu naught. Now, we have one more thing, that sigma square variance is unknown to us. So, but So how will you work with that? Because last time we subtracted the t with given mean and divided it with the variance upon square root n. Now what will you do? You do not know what is your variance.
Sample variance.
Sample variance. You will take the help of sample variance. Fine. So it will be like s by square root n, right? And let's say s is our s square is sample variance. Greater than c minus mu naught upon s by square root n. Now what next? You did all this stuff to make it.
T-test, ma'am.
Yeah. This will, now this is a random variable which will follow t distribution. Okay. For t distribution also we have some CDF known to us. So this is nothing but probability of
T of
t
n minus 4
n minus 1. What this n minus 1 represent? Degree of freedom.
plus 1 degree of freedom.
Degree of freedom is number of independent variables that can be estimated. Now we will not go much deep onto that, but okay. So this is t distribution whose CDF is well known to us. So once you know the CDF, how will you deal with this quantity? Because generally CDF is probability that your random variable is less or equal to some value k, right? That is CDF.
One yes, ma'am.
One
1
minus.
minus f of t of n minus 1 of c
Yeah.
minus mu about s upon root n.
Yeah. So these values will be given to you in examination also. And here the significance level is 0.01. Taking the inverse and all this stuff, you can easily find what is the value of C. Now, whatever the value of C will be, you will just check what is the you will be given with particular sample. Just calculate x bar. If this x bar, the value of x bar is greater than C, in that case, you will reject your null and accept the null alternative hypothesis, right? Reject null. Okay. So this is how this t-test will work. Okay. If x bar is greater than C, we will reject null. And if x bar is less or equal to C, in that case, we will accept null hypothesis. Okay. Any doubt here?
Yes, ma'am. I have a small doubt.
Yeah.
Sometimes in a t-test or z-test, sometimes we do 1 minus fz or ft, and sometimes we write the alpha is equal to direct f. I'm a bit confused regarding this. Like when to
Okay.
use 1 minus and when to not use 1 minus that. Can you please
Okay.
clarify?
Have you learned about CDF?
Yeah,
Obviously, yes.
yeah,
Cumulative distribution function, right?
yeah.
What it says, if x is a some random variable which is following, let's say, some normal distribution, okay, with mean 0 and variance 1, and I am asking you probability that x is taking value less or equal to some 10, then what will you tell me?
Minus 10 less than x less than 10.
Why minus 10 less than x? This is probability that x is taking value, probability of random variable taking the value less or equal to 10. That means you are see this kind of distribution we have, right? When we are talking about the normal distribution, right? This is the distribution for your x, right? X is following normal distribution. Now someone is asking the probability that x is taking value less or equal to 10. So let's say some x is equal to 10 is somewhere here, okay? X is equal to 10 here. Now, what do you mean by this probability x less or equal to 10? The area of this part, right?
Yes.
This is being given by CDF of this random variable x. So I will say this is CDF of x at a point 10. Okay?
Huh.
That is CDF. Now, Someone will ask you what is the probability that x is greater than 10. How will you answer that?
1 minus.
1 minus probability x less or equal to 10, right?
Yes, yes.
So you are using 1 minus fx of 10.
Yes.
So that is the reason sometimes we use 1 minus, because this is CDF. This is a distribution, right?
Yes, yes.
I always tell it as a distribution, T distribution. Before that, I used the word Z distribution. So if it is a distribution, then wherever probability of of the random variable greater than some quantity, that is nothing but 1 minus CDF. You can calculate using that. Okay.
I got it.
But in the above question, yeah, here. This is a Z distribution. Now probability of calculating Z less than this one, then you can directly use the CDF, right? No need to subtract from 1.
Yes, I
Okay.
got it. Thank you, ma'am.
Okay. So this was all about t-test. After that, there is one more test known as chi-square test. So, yeah, anyone, do you remember when to use chi-square test?
When we known the value.
When we,
Sorry, ma'am. Variance is unknown.
whenever variance is unknown. In the
Yes,
above
ma'am.
case also variance
No,
was unknown.
no. Population variance is known.
Population variance is, sorry,
Then we have to test for variance, we have to find the variance.
exactly. See, in the above two cases, we had n random variables which are IID normally distributed, okay, but we are testing for a mean of the samples, mean of the population, right? Now, let's say there are n random samples which are IID normally distributed with some mean and with some variance sigma square, obviously unknown sigma square, okay, and there is someone the null hypothesis is given, or we are going to test about variance of the population, okay, variance of population. The test is being conducted for the variance or standard deviation, let's say, okay, or test is being performed for standard deviation. That means sigma. So let's say sigma naught mu naught. So instead of testing for average of the population, in this case, we are going to predict or infer about the standard deviation of the population. Are you getting my point? So this time, let's say your null hypothesis is yeah, what it should be. Let's say it is
Sigma is equal to sigma naught.
sigma naught. It may be possible that sigma is greater or equal to sigma naught, sigma is less or equal to sigma naught, or anything, right? And what will be your alternative hypothesis?
Greater.
H1 is, let's say, sigma is greater than sigma naught. Or you can take sigma less than sigma naught or sigma not equal to sigma naught, depending on context of the question, okay? This, whether to use this one or this one, all this stuff depends on the question, what the context they are using, okay? Are you getting it? Like, so
Yes.
the main difference between the previous question and this question is what? Till now, we were checking or testing for the mean of the samples, right? This time, we are testing for variance of the samples, variance of the population, sorry. So, how to proceed with this? So, always the step is clear that first read the question, and find out what context is that, with what hypothesis you are going to test. That is the second stage. But create your null hypothesis and alternative hypothesis for the samples. And then the third step is define your test statistics. Okay. So let's say we are taking sigma greater than sigma naught. Okay, just removing this for now. Okay, so null hypothesis is this one. What should be your test statistics in that case?
S squared greater than C squared.
T greater than C. Okay, you can take squares also, no problem. Yeah. So what is your T here?
T is equal to S square is equal to 1 upon n minus 1.
So whenever I say test statistic T greater than C, that means
Sample value.
we are saying that if T is greater than C, then we will reject H long. Okay. That is traced. We are defining. But what is T there? T is sample variance.
Yeah.
Sample standard deviation. Sorry, as I took it like this. Sample standard deviation. Okay. So which standard deviation will you take? Biased, unbiased? What will you like to do? Take there? N minus 1 or n?
N minus 1, ma'am.
Why?
Because it's sample.
Yeah. What?
Because it is sample.
No. I am asking why are you taking n minus 1 here instead of n?
Yes, ma'am. Yes, ma'am. Because it is a formula for the sample variance.
Okay, but sometimes we have taken S square as 1 upon n also, right?
Then it would be population variance.
No, that's not correct. That is also a sample variance. The thing is, when we take n minus 1, this is an unbiased estimator for the population variance. Okay, this is unbiased estimator. Unbiased standard deviation. Okay, so if we want to infer about the population variance, then obviously we will take unbiased thing, right? Unbiased estimators instead of biased one to get the accurate result. Okay, fine. So after S square, you have defined a T test S square. Then what next? What to do now? We have defined
null when T is greater than C.
Yeah, that we have written there. Reject null whenever T is greater than C.
Then we will
Alpha
find the
equal to probability of reject H naught
Okay.
given H naught.
Alpha, let's fix alpha. It is 0.05, let's say. And this is nothing but probability of rejecting null when it is true. So H naught is true here. That means
sigma is equal to sigma naught.
Greater than C.
yeah, sigma naught. Right. T greater than C, given that sigma is equal to sigma naught. Now what to do? So we know about the T sample variance, right? It is sample variance, and they are saying the population standard deviation to be sigma naught. So then
Divide the both side with the n minus 1 upon sigma naught square.
we will have
N minus 1 S.
T square greater than C square, and also divided by sigma naught square, and also multiplied by n minus 1. Why I am doing all this stuff? because after doing this kind of thing, I get to know that this is going to follow a chi-square distribution.
Chi-square n minus square.
Yeah, n-1 degree of freedom. Once I know this is some particular well-known distribution, I have one benefit that I know it's PDF and CDF, and then after that I will say, okay, this is chi-square distribution. So I have its table, and using that CDF table, I can find out what this value is going to be, right? So this will be 1 minus f distribution, sorry, f value of -1 at a point this year. And taking all the inverses on all these things, we will be able to find out the value for C. This critical value we'll get to know. Once we know the critical value, we will calculate the sample using the given sample. We will find out the value for S. And if I get to know that S is less than C, then what I will do? Accept null, right?
Yes, ma'am.
Null hypothesis. Okay, so this is all about chi-square distribution. So the thing is, we should be aware about once you modify your random variable, what distribution it is going to follow. Now, what is chi-square distribution? Whenever we take the ratio of two variances, at that time it will follow chi-square distribution with n-1 degree of freedom. Okay, that is what chi-square distribution is. Fine. After that, so we have learned this z-test, t-test, and chi-square test.
Ma'am, p value is also there, no?
Yeah, p-value is also there. I am going to come to that point only. First, let me clear when to use which test. How will you check that? Because that is most important.
Z-test is used when variance is known.
So
And
first
we have
of all,
to
z-test and
calculate
t-test
for mean,
both will be used when we
for
are
mean,
testing for mean.
sample mean.
Yeah. Whenever we are going to check about the mean of the population, at that time, we'll go for the z-test and t-test. Now, if variance is known, in
Then
that case,
Z-test.
we will go for the z-test. If sigma square is known, then we will prefer z-test. Okay. And if it is unknown,
Then t-test.
then go for the t-test. Then t-test. Okay. And chi-square will be used whenever there is a question about variance, or we are testing our hypothesis for the variance. In that case, we will use chi-square test. Okay. Independent of whether the mean is known to you or not, because you will find out that in the whole thing you do not need the mean of the population. Sample mean you can easily calculate from your given sample, right? Now let's come to the p-value. What is p-value? Yeah, anyone? What is p-value?
Lowest significance level.
Yes, ma'am.
Lowest significance level.
Where
Then what?
we reject null.
Where we reject null. That is the definition, right? This is p-value is nothing but the lowest significance level. Should I write it as alpha? Is it fine? Lowest value of alpha where we
Yes.
reject null, right?
Yes, ma'am.
But what does it mean? So, yeah, anyone would like to explain?
What, ma'am?
That critical value will be provided, ma'am. we can use, it will be given either the sample mean or the sample variance will be the critical value.
We will put
Okay.
C is equal to T in the computation of significance level alpha.
Yeah, correct. But why to use p-value? So, see, whenever we are having a hypothesis test, I am saying sometimes I am taking alpha as 0.05, right? Sometimes I am taking alpha as 0.01, right? But p-value is that value of alpha for that lowest value of alpha where we reject null. And that is what our actual critical value will lie there. Okay. Till now, what we used to do, we were having fixed value of alpha, right? And after that, we are going to find what is the value of C, right? That's what we are doing till now, right? We were fixing alpha, then we are calculating value of C, right? Now, let's say alpha is not given to us, and we have to find probability of, let's say the same thing again, reject null, and it is true. Let's say the first case only probability, let's say mean, we are checking for the mean only, mean is mu naught, and H1 is saying that, okay, mean is not equal to mean naught, say, let's say, and variance is known to us. Okay. So which test would you like to test?
Z test.
Z test. Okay. So test statistic will be T. Okay. Reject null whenever T is greater than C. Okay. So reject null, that means T greater than C, given that the value is mu naught. Now, what will you do? The same criteria, same thing, T minus mean naught upon what? Sigma by square root n, right? Just
Yes,
to
ma'am.
make it Z distribution, that's it.
Normalization.
Yeah, normalization. So now, we do not have the value of alpha, we do not have the value of C, how to calculate this thing? So, whenever this kind of situation appears, we always are provided with the critical value. Okay, this critical value, let's say it is given 8.5. Then we will use this critical value, or generally they will not say it is the value of C, they will say the critical value for the sample mean is 8.5. So you have to put the 8.5 here, and using that you will have Z distribution of 1 minus 8.5 minus mu upon sigma by square root n. Obviously this mean naught is given to you, sigma is given to us, n is given to us, and by Z table we can find the value of alpha, right? We will have some value, let's say k. So alpha is k. So what this k is your p value. That means this is the lowest significance level where you will reject null. Now, how do you say that this is lowest value? Where will it lie? Do you know actually where the alpha lies in the graph? Anyone? Don't you ever? Yeah. Yeah, what?
Argument of x-axis maybe.
Okay. So whenever this kind of graph is there, what do you think? What this x line is denoting? I say C is lying somewhere here. T is greater than C was our test, right? T is greater than C. Okay. I always say the C is lying here. I always put C here, right? This is acceptance region. This is rejection region. If T is, if the value of C is lying here, that means this line is representing what? Sample mean, or X bar, you can say. This is the line for X bar, right? X bar or whatever. If you are checking for the variance, then this is your what we say, taste statistics are lying here. Okay. So where alpha is? If P is greater than C, if your sample mean will be greater than C, then will lie here and you will reject your null hypothesis, right? That's what. So where alpha is?
Alpha is the shaded area, ma'am.
Okay, shaded area, fine. You are like it's correct answer. The shaded area is your alpha value, because alpha is what? Probability of type 1 error, right? And if you can see, if you observe here also, sorry, here I have done one mistake. Should be 1 minus fz value of this. Okay, yeah. So alpha was probability of this thing, like T is greater than C, given that it was true. So this value is K. Actually, alpha is significance level, that you know. It relates with the confidence interval, but till now, whatever we have studied, your answer is correct. This is the shaded area is our alpha. Fine. Now, what? So your p value from the given situation, your p value is K. Okay, fine. Now I ask you one question. Let's say for any particular question, p value is given to you or you have calculated, it is K. And now someone comes there and say, if p value is given to you as K and alpha K is equal to, let's say, 0.06 and alpha is 0.05, what will you do? Will you reject your null hypothesis or accept? Can you judge based on this information? You have p value, you have alpha value. What will you do? From this information only, you can you answer or not? So your first question is yes, no kind of question. If p value is given to you and alpha value is given to you for a particular question, and asking for, can you answer about whether to accept or reject null?
We will accept, ma'am.
You will accept. Why?
Yes, because alpha is less than p value.
Alpha is less than p value. Okay, then.
And that's why we are.
Okay, then. That's why you are accepting, but why?
Because, ma'am, p is a minimum threshold. P is a kind of error, minimum error we can go with.
Okay.
Yes,
So
ma'am. That alpha will come to the right of C, ma'am. So it is within the rejection area. So we will have to accept it.
So you are saying accept null, right?
Yes.
From this information, you guys are saying accept null.
Correct.
Okay.
Yes, ma'am.
But I am asking for the like logic behind that. Answer is correct. Yeah.
Alpha and K are within the shaded areas. If K is greater than this alpha, then alpha is falling in K.
Okay. Alpha is falling in K. Okay.
So we can say that that alpha is confined within K.
Alpha is, sorry.
Okay.
Okay. So what is the definition? Okay, I'm just again, your logic is also correct. P value is what? The definition we say it is the lowest value of alpha for which we reject null, right? So lowest value of alpha for which we reject the null hypothesis is 0.06, right? 0.06 is the lowest value for which I will reject my null, right? That's what the p value. Can I make this a sentence in terms of this particular value 0.06? See, you guys only give me the definition, right? Lowest value of alpha where we reject null. So if p value is 0.06, that means this is the lowest value of what? Alpha, right? This is lowest significance level. This is lowest significance level where we reject null, right? That means what? What does it mean? Whenever
We should
the,
reject for 0.05.
okay, but let's just take with this. What does it say? P value, that means if your alpha value is less than p, then what should we do? Accept the null or reject the null? So 0.06, yeah,
Accept the null. Ma'am.
accept the null. Okay. Lowest significance level where we reject null. Now just graphically visualize it. The p value is the lowest alpha value, right? Where we reject null, that means that will give us a rejection area, right? Let's say this is some value c and this is 0.06, right? That is your like area we just sometime before we discussed, right? This is 0.06. Now alpha come to be 0.05. Now at that position, like that means this alpha is inside your region, like someone give me that description, right? That alpha is going to be covered in this part. That means what will we do at that point? Just think about that.
We should reject everything beyond C.
Yeah, what? We will?
We should reject everything beyond C.
We should reject everything beyond C, right? Beyond C, we should reject, right? That's for sure.
Alpha,
Yeah.
So alpha is in from that region, so we should reject.
So what? Alpha is?
From that region, rejection region. So we should reject that.
Yeah. Okay. And okay. Do you agree with what's your name? With him? Okay, I'm giving 1 minute. Everyone, you just think about that. Whether to, if I have p value given to you as 0.06 and from some information or from some given sample, you got to know about the significance, like you have checked about the, or by somehow, by question only, you got to know that you are you're checking for the significance level 0.05. And you already know your p value. So should you go for the whole test again, or can you answer it from the p value and alpha value only? So I say, yes, you can answer from the p value and alpha value only. If you have the p value and someone is asking whether the null hypothesis is correct or not at a significance level of 0.05, there is no need to do all the tests because you know your p value. And p value is what? Lowest significance level where we will reject null hypothesis. Okay. So if p value is greater than your alpha, which is being asked at that time, what will you do? That is the question.
Reject. If alpha is greater than p, we will reject.
We will accept. We will accept. Initially only I told that answer is correct given by you guys, but I was seeking for the valid logic. What logic you are going to apply? See, I will try to explain in reverse manner. Your p-value is what? Lowest significance level. Where will you reject? Let's say p-value is less than your alpha, right? That means your alpha is greater and p-value is less. In that case, what will you do? Directly say what? Reject null hypothesis. Why? Can you explain this? Just forget about all the above discussion and just tell me about this. You have p-value as 0.04, okay, and alpha is given to you as 0.05. No need to check, directly say reject null hypothesis. Why? Because p-value is the lowest value where you have to reject null, right? P-value is the lowest value. Are you getting my point? If
Yes, ma'am.
the same thing is there and if I reverse, p-value is greater than alpha, in that case, without thinking anything, accept null. See, this is kind of confusing sometimes, but just remember the definition that lowest significance level. What do you mean by lowest significance level? That means if you take the value of alpha less than that value, in that case, what will you do? You will accept, right? This is the lowest value. After this, what we say, lower value, if you come to any value which is lower than that, I will not reject my null. That is what the definition, right? Lowest significance level where I will reject my null hypothesis. Okay. So once you said that your lowest significance is 0.06, okay, that is your value of k or p value. That means what? Whenever you come up with the alpha which is lower than this value 0.06, I will not reject because my lowest for rejecting is 0.06. So whenever p value is less than, or for above question, my p value was greater than alpha, right? I know what is my rejection criteria, what is my lowest rejection value for alpha, right? If it is 0.06 and you are coming with the alpha, you are coming with the significance level which is lower than my rejection value, I will accept null in that case. Okay, so be careful. This is confusing, but just if you keep in mind the definition of p value, then you will save your lots of time. Yes, you can unmute and ask it out.
Ma'am, what if both are same?
If both are same, then what do you say? What should be done there?
Ma'am, I think we reject.
If they are same, that means your alpha, that means your p value and alpha value are same, and p value is the significance level where you have to reject, right? So you will reject null. Okay. So actually, p value is also alpha value, but a particular alpha. That means lowest value of alpha for which we will reject a null. Okay. Are you getting it? Yes, whoever want to.
Yes, ma'am. Ma'am, yes, ma'am. Can we interpret p value as the highest confidence level for our decision?
Highest confidence? No, not highest confidence.
Ma'am, because if alpha is 0.05, then our confidence, we say that we are 95% confidence in our decision. And
Yes.
because we are saying that P value is again lesser than alpha. That means 95, like there is a percentage which is greater than 95, number which is greater than 95.
See,
So I was setting it like that.
yeah. It's not highest confidence, but we say, see, in any question, in any scenario, you either you know what is p value, or you may have information about critical value. See, critical value or p value are same, right? Because any of the thing you know, you can find alternatives. Critical value, or you know about the alpha or significance level alpha, right? Either like three of things, out of these three you will know any of one thing, and based on that your confidence interval will depend. So I will not say if like whether it will be highest confidence or not, but yes, for a p value, that will be the most trusted what we say answer whenever you have the p value, but that is most trusted for that corresponding critical. Once you change your critical value, your p value will change, right? Are you getting it? So they are connected. Okay. And in real life, when you will learn, when you will practice with this thing, what we say, with data, at that time, even though your confidence, you are getting some reason, let's say some result with 95% confidence interval and some result with 90% confidence result, you may have to go with this 90% confidence interval result, because these are some factors, and there are a lot more factors that are yet to learn about. After that only we make our decision. Not we do not take decisions based on this significance level only. For example, we started with random variable, its distribution, then we learned CDF, and now we are studying hypothesis, right? All these are connected. Now you will learn more tools in your next what we say courses, and then you will get to link all these things. Okay. Okay, fine. So this was all about one sample test. Why one sample test? Because there are random variables for one criteria only. Now we'll have two sample tests. But yeah, your answer for that, that is not what we say. What was your question? Is it a large? What? Can you repeat your question? So that is not the highest for yeah. That the p value will not give you the highest confidence interval, because if you lower your alpha, your confidence interval will increase. Okay, because
Ma'am,
yeah.
Ma'am, in that case, can we say that, for example, say the sample mean will be very close to the population mean?
In which case?
Like when the this p value, if the the alpha value, if it is suppose smaller than the whatever it will be in case of p, if it is smaller than that, then whether the sample mean will be very close to the population mean. Does it mean that?
Sample mean will be a close to no. See, all this confidence is about your estimation. That estimation is going to be correct at this confidence. That has nothing to do with the whether how far it is from your what we say sample and population. See, I will draw two diagrams. Okay, this is p value. Okay, this is your critical point C, and this is your p value. Fine. So where I have written p value, this is your rejection criteria. If you just take decision based on this, Now there is someone coming with the alpha value. Okay. And alpha is less than P. Okay. So obviously this C will shift towards left or right? Right only, right? This is alpha
Yes, ma'am.
value. Right?
Yes.
Now what happened? Your acceptance region increased.
Yes. Yes.
There is
Yes.
no change. For example, this one is your population mean, right? Generally, the center point is your sample, population mean only. These are the values of X bar here. Okay? X bar here. So, nothing is happened when you take alpha, like when you change your alpha value. What changes? Your critical value was C here. Now here, the boundary shifted towards here, right? So the change is there. Your acceptance region increase when you decrease your alpha significance level. Once you decrease your significance level, your acceptance region increase. Nothing much happened there. Okay.
Yes, ma'am. Yes.
Is it giving you visualization?
Yes,
Like
ma'am.
what
Yes.
happened? Okay, fine.
Ma'am,
Yeah.
ma'am, I have a question from a problem point of view.
Problem?
Ma'am, like how we solve the problems regarding p-value.
Okay.
Ma'am, can
Yeah. The same thing we did there, right? Okay. For example, question. Let's say there is a company which have which have production of containers. Okay, they say that their container can hold 1 liter of liquid. Fine, liquid. Let's say, for example, the container can hold 1 liter of liquid. Someone has taken 100 samples and find out what is the volume for that container. Okay, like company has produced a container, they are saying that uh, uh, limit to contain like that container can hold 1 liter of liquid, milk, water, whatever. Okay, so for a practical purpose, for a research project purpose, someone took 100 samples and they found that no, this is not a 1 liter. This containers are not taking one like can hold 1 liter. It is less than 1 liter. So okay, so they said volume is not 1 liter. Okay, and this company also have taken obviously some amount of container, and after that only they said that average they are taking it can hold 1 liter liquid. They said the p value for the particular taste or sorry, variance is also given to you as 9. Okay, it is normally distributed in all this stuff. So 100 samples are normally distributed with some mean and variance 9, and got to know that volume is not 1 liter, it is less than 1 liter. Okay, and then they have given the p value is 0.05. Then at a significance level, then find your answer at significance level. What we say, level alpha 0.04. This kind of question will be there. Like I have instant. So this is question. Do you understand that? The company says that their container can hold 1 liter of liquid. Then someone for the research, someone to clarify, they have taken 100 random samples having variance of 9 they found that the volume is not 1 liter, it should be less than 1 liter. Now, what should be your null and what should be your alternative hypothesis?
It's not a,
Yeah, what?
1 liter now.
Okay, it's 1. And what about alternative?
Greater than 1.
Less than 1.
Less than.
Okay. H1 will be less than 1. Okay. So again, this question is recently formed. So if you calculate it, I don't know whether it will match the p-value and alpha value answer and with your z-test, because obviously we know the variance, you can use z-test, right? Your test statistic will be what? Reject, null when p is less than c, right? Now you can calculate what is the value of c and all this stuff there. And at a significance level, you can, at a significance level 0.04, you can find out whether the value of t is less than c or not, and you will decide whether to accept the null or reject the null. But with p value, you will get one more thing directly, that p value is 0.05, significance level is 0.04. Directly you will what? Accept the null hypothesis. But tell me one thing, accept the null hypothesis at the significance level of 0.04. Is it the correct statement?
Ma'am.
So I'm just deleting it. Why? Because all these numbers I have taken randomly. So it may or may not coincide with the z-test. So do not take this kind of steps. But yeah, the question will be like that. If p-value is 0.05, what will you do at a significance level of 0.04? So as we know that if p-value is greater than alpha, in that case, what will you do? Then accept.
Yeah.
Accept null. But the sentences are incomplete without saying that, then accept null at significance level of what?
0.05.
4. 0.04, not 5.
Okay.
Accept null at significance level of 0.04. So always be clear at what value of alpha you are accepting the null or rejecting the null. It matters a lot, this number. Once you make it 0.05, your answer will be incorrect, because at 0.05 significance level, we are rejecting null. Okay. So maybe this kind of question may appear in your any of the entrance exam, that if this much information is given, then there will be a options accept null at significance level 0.04, accept null at 0.05. What will you do? So 0.05 is incorrect option. You are going to accept null at a significance level which is 0.04. Or in short, you can say that accept H naught at a significance level whenever it is less or equal to, less than 0.05. Okay. Because,
So we
yeah.
accept and reject always at the significance level alpha value.
Yeah. Yes. Yeah. What is
Ma'am?
your question? Continue.
Can this p value be greater than alpha?
Yes, it can be.
Can
Here
this
it is.
p value be greater than alpha?
This scenario is giving you p value greater than alpha only, right?
Is it possible that p value can be greater than alpha? Because it is the lowest significance value.
Yeah, it is greater than. It is greater than. See, 0.05 is greater than 0.04, not? Isn't it?
Ma'am.
What's your question? Are you getting me? Like, what are you asking?
No, ma'am. As as in graph, this is p value is the lowest alpha.
P value
Right.
is lowest alpha, yeah.
Lowest alpha. So we are reducing that area under the curve.
Yeah. We are reducing p value is the lower. See, this p value is the point for which this is the like what we say, whenever given critical value is given to us, then p value is the lowest significance level where you will reject the null. Okay, so once you fix your critical point at the value c, then if you come up with any alpha which is less than p value, then I am going to accept the null. Why? Because my lowest was c. Sorry, this p value. Is it clear to you? It is actually
Out in p value in alpha, that is it area under curve?
Yeah.
Or p is the point on x-axis?
No. P value is the p value is what? P value is the lowest significance level, right?
That is area under curve.
Area under the curve. Yeah, both
Yes,
are the.
if it is the lower significance value, then this we should shift this c towards the right in order to reduce this area.
Yes.
So that area is always going to reduce. So my doubt was, is it possible that the p value can be greater than alpha in any way? Because p is the smallest values, means that p value is always the smallest area than alpha.
No, it is not. It is not.
Ma'am, actually, definition is p. It is the lowest alpha value where we reject
the null hypothesis for a critical point c. Yes, unmute yourself.
Yes, ma'am. Ma'am, I was actually.
Okay, you are on. Okay.
Actually asking if we have to find the p value. Ma'am, am I audible?
Yeah. You have to. Yes.
Ma'am, I am asking if we have to find the p value, then suppose using the calculation we have got the c value.
Yeah.
We'll directly put it in our fz value and we'll get it.
Yeah.
In case we do not have the c value, then are we going to use the sample mean or the sample variance?
There is no then. You need the value of c, only after then you can have the value for p, that p value. See, what is critical value? What do you mean by the critical value? You have learned enough maths, right? Maths and physics also. Critical value. What do you mean by the critical value?
Ma'am, it is a function shows some change.
Yeah, this is the point after which your trend of anything will be going to change, right? Or threshold value in physics we say it as threshold, right? So whenever you want to find the lowest significance value, that means this value, when this alpha is the lowest significance level for a particular scenario, at that time I will say it as a p value. Otherwise I am going to say it a significance or no. Okay, so whenever you know that the c is some value t, then only, so what will you do? I will just put probability t greater than small t such that h naught is true, right? At this, when I solve this probability, at that time this alpha is known as p value. Okay, and this p value is the lowest value of alpha for which I will reject the null whenever when my critical was t. The complete statement is like that. Okay, so once you put your critical value as which is given in the question, let's say it is t, at that time whatever the alpha is going to be calculated, that is your p value. Okay, in any question either you will be given the value of alpha or the value of c. Okay, if they are giving you the value of alpha, you will end up your calculation by getting the value of c, right? That was the question we have done till now. But whenever you have been given with the value of C, you will end up this calculation by getting the value of alpha, right? The simple mathematics, in one equation, if there are two unknown, then one has to be given to you so that another you can calculate, right? Are you getting my point?
Ma'am, I have one small doubt, ma'am. When you are
Yeah.
calculating p value, you will get it as some fz function, correct, ma'am?
Yes.
That value we have to compare with fz of 0.05. If I have to say if p value is greater than alpha or p value is less than alpha, correct, ma'am?
Yeah. Fz of 0.05, why?
Minus 1.64 or something, ma'am.
Yes. 1.6.
Yeah, that I have to compare with fz of whatever value I got for p, that the function which I'll get, correct, ma'am?
Yeah, that is one way. When you go with the Z table, that is actually another way. But when you want to directly go with the alpha, you can directly go with the alpha values and p values because both are. See, just tell me one answer. When you compare two things, whenever they, when we can compare two, what we say, entities?
So, oh, okay, I know what you're telling, ma'am. Fz of, because I had this doubt in the tutorial question, there is two questions like that, ma'am, because the answer of P was Fz of 1.35, that is the value of P. And they are asking whether we have to, whether it will be, whether we can accept or reject H0 if the significance value is 0.05.
Okay. So did you get my question? When, like, question is, when will you compare two entities? When they will have same nature, right?
Correct.
The mathematics says you can't add 1 plus a. Why? Why? 1 is a number, 1 is a letter. You can't add them. Why? That is not the rule. But p value and alpha value both have the same thing. Both have the significance level, right? So whenever you have to compare, directly compare p value with the alpha value instead of whatever inside there or outside there. Okay. Are you getting my point? Like, does it clear your doubt?
Okay.
You can directly have
I got it.
comparison
Okay.
between p value and alpha value because both are the significance level only.
So 1.35. So I got fz of 1.35 as the p value. So I can directly compare 1.35 is greater than.
No.
That's the doubt, ma'am.
1.35 is your taste statistics. This is your taste statistics.
Okay.
You can't compare this with the alpha value. You have to find the fz value of this 1.35. Then only you will get your p value, right?
Correct.
What is your p value? Your p value is CDF at a point 1.35.
Okay, I got it.
Do not compare this 1.35 with alpha. Yeah.
Okay, I got it, ma'am. Because in that answer it was given like that. That's why I got confused. So you have to find fz of 1.35. That will give the p value.
Yeah.
Similarly, I have to find fz of 0.05. That value I have to compare. Got it, ma'am. Thank you.
Yeah. Okay. So, yeah, definitely. In the first look, this may look like confusing, but make a clear notes. Then only you will be able to distinguish it. Still, if there is any doubt, we are going to meet on the Tuesday, so we can have discussion on that day also. So, should we move to the two sample test, or if there is any question, then I can go with that also. Okay. So let's start with the two sample test. So my suggestion to you guys is, whenever you study hypothesis testing, make your own notes for which test, when to use, how to compare when p-value and alpha value is given to you, how to check whether to accept or reject the null based on p-value, alpha value, based on taste statistics and C value. Okay, these are several things that we study. So make clear notes, whatever suitable to you. Okay, because there are many terminologies we use there, and there are many criteria to check these things. So we make your own notes so that you can check it. Okay, 2 sample tests. So let's say till now we were dealing with only 1 sample test. Now let's say there are some n random variables xi's which are following IID, like which are independent and identically distributed following normal distribution with mean mu1 and variance sigma square and y1 to yn2, let's say n2. So that it may be possible that your n1 and n2 are different. This is also IID samples following normal distribution with mean mu n2 and variance sigma n2. Okay, so this kind of 2 samplings are there. So obviously their mean of n1 random samples and n2 random samples may or may not be same or greater than that or something like that. So whenever there is a testing for this kind of 2 samples, at that time what we'll do, there will be some new test known as 2 sample Z test and one will be F test. So there are 2 unknown parameters. Maybe we are, let's say we are testing for mean. Null hypothesis says that mean of n1 random sample is greater than mean of n2 random samples. Okay, then what will be your alternative? As I said, it should complement your null. So that will be even less or equal to mu n2. Fine. Then based on that, we have to define our test statistics. One more thing to note that these xi's are independent and identically distributed among themselves. But this xi and yi, they are also independent. They are not dependent, okay? This xi and yi's are also independent. So now H0 and H1 we have defined null and alternative. Then what next? Our steps are very clear. First define your null, alternative, then your test statistics. What will you do? Test statistics. We are going to
X bar minus Y bar.
We are so from this problem we are going to infer about whether the mean of the n1 samples, that xi samples, is greater than the mean of yi samples, right? For the population by studying the samples of xi's and yi's. Okay. So this the question, the inference is about what we say mean. So obviously our test statistics should be something regarding the sample mean. Let's say x bar minus y bar. So if this difference is greater than 0, then what will you say? Your null is correct, right? Otherwise, yeah. So T should be greater than C or less than C. What will you say? I have given hint indirectly. If T is x bar minus y bar, what should be your rejection criteria?
Less than equal to null.
Reject H0 if, yeah, what?
Less than or equal to, yeah.
Okay.
Yeah.
This is sample mean for x1, xi's. This is sample mean for yi's. So if x bar minus y bar is less or equal to C, that means x bar is less or equal to C. Sorry, y bar, right? X bar minus y bar less than C. That means what? You are going to reject in that sense, right? These both are same thing, right? T less or equal to C or x bar minus y bar less or equal to C.
Yeah, correct.
Yes, ma'am.
Okay. So yes, you are correct. So this is our test statistics. Now what to do? So T is x bar minus y bar. Xi's are normally distributed, yi's are normally distributed. So what about x bar? X bar is also a random variable, right? Sample mean, but it's again a random variable. What will be its distribution? Again, normal distribution. What will be its mean?
0, mu1 minus mu2.
I am talking about x bar, not x bar minus y bar. See, x bar is a sample mean for the xi random x1, x2, xn1 random variables, right? So its sample mean is the same as the population mean. But what about its variance?
Variance.
Sigma square by n.
Sigma square upon n.
N1. Yeah, N1.
Sigma square n1 by n1, right?
Yeah.
And what about y bar? Then again the same thing. It's normally distributed with mean mu n2 and variance sigma square n2 by n2. So we are looking for the t. So what will be the distribution for t? T is x bar minus y bar. Both are normally distributed. So its distribution will be again a normal distribution, right? And what will be mean? Mean will be the difference of two.
Yeah.
And what will be the this one? So square. Yeah, sum of them. N2 square by N2. Okay, fine. So that's what about T. T is following this distribution. Now I want to check at a significance level of 0.05 whether this condition is true or not. So what should I do? This is the difference, right? This is difference. And the question is about whether it's greater than or not. What should I do then? Alpha is probability of rejecting null. H0 when it was correct. It's true. H0 is true means mu n1 is greater than mu n2. Can I say mu n1 minus mu n2 greater than 0? Right?
Yeah.
So, from this, one small mistake, we can't have this kind of stuffs. That's all it means. Actually, we have just randomly taken this, so this kind of mistakes won't happen. But still, we can take because this is a 1 point and this is a continuous distribution. So 1 point will not disturb that much, but let's take it like that. So, to avoid the confusions. So probability of rejecting H0 means T is what, greater than or less than C. Given that H0 is true, that means mu n1 is greater or equal to mu n2. That means, can I say that mu n1 greater or equal to mu n2 will be mu n1 minus mu n2 will be greater or equal to 0. So how should I proceed? Can I take the difference as equal to 0? As we did in the last question also.
Yeah.
So t minus mu n1 minus mu n2 upon what? Just take it as a sigma t. Is it fine if I take it like that?
Yeah, correct.
Okay.
Yeah.
This is less than C, sorry. This is less than C minus mu n1 minus mu n2 upon sigma t. Given that H0 is true. Okay, H0 is true means we can replace this value by 0. So this is probability of T by sigma T is less than C by sigma T. So just come back to this one, this part. If I take this part as to be 0 and this part is sigma T, and after that I just divide T by sigma T, then what will happen? My T distribution, this T by sigma T will follow a normal distribution with mean 0 and variance 1. That is nothing but the Z distribution. So I will say this is probability Z less than C by sigma T, right? So once I know it is a Z distribution, I will just write it as a fz of c by sigma t and will get the value of c, and based on that I will define whether the null hypothesis is acceptable or not, right?
Yes.
Okay, once you get the value of c, just check, just find the value of t and compare them, and if your t is less than c, then reject the null hypothesis, right? Reject null. Okay, so this was about two sample Z test. Similarly, there is a last test which is two sample F test. So in two sample test, there is two things, right? One is mean, one is variance. So we checked if we are testing for the means of two samples, then what are we going to do? And now we will look what will happen when we are checking for two random variables with for their we say variance. Just a minute. So let's say this is these are the two samples for us, and we are checking for the variance of them. Like let's say our null hypothesis is whether the samples of variance of two IID samples were not two samples are same or not. So null hypothesis says that they are same, and the alternative is saying that the variance of N2 is greater than let's just say it N1 instead of N2. N1 is less or equal to N2. Okay, in that case, now as we discussed in chi-square, whenever like z-test, t-test will be used whenever there is a testing for mean, but whenever there is a testing for variances, we'll go for some another test. Here it is f-test. So H0 is saying that they are equal. The variances of two samples that are being studied are equal, and null hypothesis, alternative is about one is lesser than another. So what will be our test statistic in that case? Yeah. What should it be if we are going to check about the samples?
T less than C.
Yeah, what?
T less than C.
Sorry, T less than C. Okay, but what is T actually?
Sx means the sample variance of the ratio of the
yes,
two.
correct. The ratio of sample variances of both the samples, right? Sx square by Sy square. So, okay. So these are the sample variances for X and Y respectively. After that, what should we do? So before going to further, I will say that if we are, just tell me one thing, what will be the Sx square by sigma n1 square? This will follow, I just told, no? Whenever there is a ratio of two variances, or I'll just multiply it to n1 minus 1 only, the ratio of variance, population variance and sample variance multiplied with this factor, it will follow a chi-square distribution with n1 minus 1 degree of freedom. Similarly, if the thing is n2 minus 1 by sy square by sigma square n2, then it will follow a chi-square n2 minus 1. Okay, these are some distribution that follows like that. If you take the ratios of this kind of variances, you will get a chi-square distribution. But what if your sigma n1 square, or in general, I want to say that if you will take the ratio of 2 chi-square test, that will result into F distribution. Okay, the ratio of 2 chi-square distribution will give you F distribution. So if sigma n1 square is equal to sigma n2 square, sorry, not square here. If sigma n1 square and sigma n2 square are equal and also n1 is equal to n2, in that case, what will be your Sx square by Sy square? Will follow F distribution with n1 minus 1, n2 minus 1. Why it is so? Because this is nothing but the ratio of 2 chi-square distribution. Right? Are you getting it? Because the ratio of 2 chi-square distribution will give us a F distribution. So, if at a significance level of 0.05, we check what should we do in terms of accepting or rejecting the null, we'll say probability of rejecting null when it is true. So that is nothing but probability of t less than c, given that sigma n1 square is equal to sigma n2 square, right? It is given to us. H naught is true. Yeah.
Can we take as yes, it is F alpha by 2?
What alpha by? Achha. Okay, when will we take alpha by 2? Okay. Just a minute, let me just finish this. I will tell you. This is a one-sided test. When there will be a two-sided test, in that case, when we talk about the F distribution, at that time we have to take alpha by 2. Just let me just finish it, okay? I will just tell. So, we have this thing. T is nothing but Sx square by Sy. So, once you take the condition that your sigma n square and sigma n2 square are same, and also n1 and n2 are same, then the probability that Sx square upon Sy square is less than C, this particular ratio is going to follow. Actually, T is Sx by Sy, right? Or square it. Okay, we have taken square. This quantity will be going to follow F distribution. F distribution with degree of freedom n1 minus 1 and n2 minus 1. So that is nothing but probability. This is the CDF, right? So let me just write it. F n1 minus 1 and n2 minus 1 is less than C. So once it's a F distribution, we will solve it as we did it till now. This is CDF. So F value of this F2 distribution at the point C. And using that, we will get the value of C and we'll say whether to accept the null or reject the null. So coming back to your question, when to take alpha by 2. So the same question, if I say, so let me just write it here. Let us say the question is about this one, but instead of this greater kind of things, the question is they are not equal. So in that case, your taste statistic will be modulus T less than C. Why I took modulus T? Because now they are not equal. That means the difference, or just instead of F, okay, that is also fine.
Is this a two-tailed test, ma'am?
Yeah.
Okay.
So in actually, if I can explain here also in short. See, in two-tailed test, for F distribution. Okay, if we are using F distribution and we ended the F distribution and we are going to have a two-tailed test, in that case we have to use something different. Why it is so, I will explain. See, till now we use normal distribution. How normal distribution was? Seems like this description of, no, sorry. The description for normal distribution is what? It is bell-shaped curve, it's symmetric, and all this you say about null, right? And normal distribution. This was normal distribution. But whenever it comes to F distribution, in that case, the distribution is not symmetric like this. The distribution is seems like something like this. So in that case, you directly can't take your modulus t less than alpha for both the sides, because somewhere here there is 0.1 we say, because we are taking the ratio of Sx and Sy, right? So at this point, let's say they both are same. But whenever you will define your alpha here, or your C1 here, point here, T less than C, let's say, not alpha. Okay. And similarly, T here, because you are saying modulus T less than C, so obviously this both the difference are same. Okay. The representation is something similar. Okay. So the see the difference, 1 to C, 1 to C, both the difference should be 1, right? Both the difference should be same, because we are saying modulus T is less than C. The difference between T and C is like this, right? So the area of rejection on the right side and area of the rejection in the left side is not same, right? But whenever the same thing happens with the normal distribution, the alpha is somewhere here. At that time, due to symmetricity, the area of rejection on the both side is same. So that in that case, we do not use the alpha by 2, but here we do. Here we say T is less than, generally we say to 1 plus CR, right side, for 1 plus, sorry, T is greater than. Whenever T is greater than 1 plus CR, reject null, right? And whenever T is less than 1 minus CL, or let's say reject null. Okay. So in that case, whenever you solve this kind of question, your alpha will be like probability of something T less than C, for example, right? This kind of thing is there, and you are going to take one, let us take it 1 plus CR. Okay. And alpha is 0.05. So you know that if it is a two-sided test, then you should not take the alpha as probability of T less than, you should take alpha by 2. And similarly, the probability alpha by 2, T greater than 1 minus CL. Oh, I'm making a mistake here. Speaking correctly, writing in this kind of stuffs, right? Did you get it?
Yes.
So that was the reason. Okay, so that was all about hypothesis testing and various tests that we use to check whether the claim or whatever we say null hypothesis is correct or not. We use this kind of stuffs there. Some 5 tests we have learned. For one sample test, we learned Z-test, T-test, and chi-square test. 2 are for the mean, 1 is for the variance. Similarly, for 2 sample tests, we learned 2 tests, 1 for the mean and 1 for the variance, right? So that was all about hypothesis testing. If there is any doubt, then we can discuss in the next session, or now also if you have. That was all about today's session. Yeah.
Ma'am, I have a
Yeah, please
doubt,
continue.
not regarding specifically hypothesis. Yes, ma'am. In the statistics marks for week 11, there is a question where there is negative marking.
Okay.
Like many students, including me, I have raised the request in the discourse. Sir has said, Prashant sir has said that we look into the matter, but then I think it is 7 to 10 days passed, and there was no change in the marks.
Okay. For that, I will check on with the team. Okay.
Yes, ma'am. Yes, ma'am. And also, ma'am, there is, ma'am, could you please tell me what is the total bonus out of?
Okay. I do not know as of now. I will like, as it's decided at the end only. So once it is decided, we will post on the discourse or in the next session if it is decided. Then.
Actually, the bonus marks have been
Yeah. What?
released already.
So
ma'am,
it should be on the discourse only, or I will put there.
Yes, ma'am, because the marks have been released, only what is it is out of that is not known.
Okay.
Yes, ma'am. And last thing, ma'am, in the extra activity, there is one peer who has like not given me the correct marks for the activity that I have done. Because of that, I think the marks have gone low. Also, for that, I want the instructors to check on it.
Okay, fine. But this kind
It
of
is extra activity
things you
5.
can mail also.
Ma'am, I have mailed to the support team. They said that once the
Okay.
marks have been published, there will be no change. But in the discourse, sir has said, like, even for extra activity, the request have been raised in discourse.
Okay. That will be resolved. Okay.
Thank you, ma'am.
Fine. Okay.
Ma'am, can I
So,
ask one question with a weak name? There are two estimators, theta 1 hat and theta 2 hat, and there are some risk associated with it. Which one estimator is the best? The one with the risk is less?
Yes, obviously.
Okay.
Generally, we one with the risk less. Yes.
Okay, ma'am.
Okay. So yeah, thank you for today, and all the best for your examinations. Okay.
Thank you, ma'am.
Thank you, ma'am.
Thank
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you.